All right, we will go into the third method of election in section 8.3. The third one is called the instant runoff election. And in instant runoff, sometimes, by the way, this is called RCV. Now, this is actually in the news in recent days because some elections in New York City just started to implement it. And if the biggest city in the country starts to implement it, and not surprisingly, a lot of confusion took place because many people did not, including some of the election officials, unfortunately, and counters, did not quite understand this. So there was some confusion, but this method is gaining popularity. And so you do need to understand this. RCV standing for ranked choice voting. Okay, so this is ranked choice voting, otherwise known as the instant runoff voting. Now, runoff election is it's actually a second huge election after nobody fails to get a majority vote. And in some places, they do a separate runoff election between the top two candidates. The only problem is if you actually hold a second election, it is very expensive. You're going to ask people to go back to vote to the ballot boxes again. And it is very time consuming, very money consuming. And so the actual runoff vote is not very preferred. So what they do is this procedure, which we will go over in just a second, and they consider this to be an instant runoff vote. The people only vote once, but the process is going to take several steps. All right, and so this is called the instant runoff vote, otherwise known as the RCV, ranked choice voting, in which the candidate first with the fewest first place vote. Okay, what's going to happen to the candidate with the fewest first place votes? Of course, the person is eliminated. Okay, so in the our preference schedule, which you'll see here in a moment, the person or the candidate with the fewest, the least first place votes is going to be eliminated, removed, taken away, okay, from the chart. And then another table is constructed without that candidate. And then we look at that new preference table, and again, the one with the fewest first place votes gets eliminated. So this person will be the second person to be yanked out, eliminated, chopped, if you will, from the table. And you repeat this. It sounds familiar, huh? You are chopped, and then you are chopped, and then you are the winner because you won. All right, so that is the procedure. You kick out the lowest or the one with the fewest first place votes. One person at a time until only one person is left. So repeat this until one candidate gets the majority, more than half, and that person becomes the winner. All right, in the above example, let's look at this example we saw first. In the above example, you noticed here that who wins in the plurality method. A won by the plurality method of 18 first place votes. B had 12, C had 10, D had 9, and E only had 6, right? So E has only 6 first place votes, 4 plus 2, the 2 last columns. And so E is eliminated first. Did you see what's happening here? Because E only had 6 first place or the top votes, E gets eliminated first in the instant runoff voting, which is very unfortunate because remember, in the Condorcet pairwise method, E actually beat everybody else. So E was not a bad candidate. Everybody, or well, not, I wouldn't say everybody, but in the pairwise or Condorcet comparison, E beats each person, all the other candidates, right? In the pairwise comparison, but in the instant runoff, because E had the fewest first place votes, 6 votes, E gets eliminated first. And so now we have this new preference table. See, all the E is eliminated, right? So now you only have A, B, C, and D in this chart. Now, because E is gone now, here is the new chart, and here are the numbers of first place votes. Take a look, okay? A still has only 18 first place votes, but look at what happened to B. because E is gone, watch carefully, because E has been eliminated, B has these 12 people who chose him to be the first candidate, but B also picked up these 4 because E is gone now, right? And because E is eliminated, these 4 ballots that had E as the first place and B as the second place, B picks up these 4 votes because when E is eliminated, these 4 people would prefer B to be their first candidate if E is not available. So B would have 12 plus 4, which is 16 first place votes now. C also picks up these 2 votes, as well as the original 10 people who voted C to be their first place candidate. So it's 10 plus 2 and 12 people would choose C. So it's almost like having a virtual election. If E is not available, if E is being removed from the possible candidates, these 4 people would go for their second candidate, which is B, right? So now you have 16 people voting for B. And then these 2 people, when E is not available, would choose C to be their first place candidate. So now we have 12 people voting for C. Now D still has 9. It's not going to pick up any additional votes. So that is the result. And if you look at this, A, B, C, D, you have 18, 16, 12, and 9. The fewest number here is D. So D gets yanked, chopped in the second movement of this show, right? So D gets kicked out. Now E is gone, D is gone. Okay, so now in the next round, we look at these numbers when E and D have been eliminated. Let me just go ahead and make different marks on this chart. All right, so we had already removed E, and now I am going to remove D. So I crossed out all the D's here, right? Okay, now only A, B, and C are left. How many first place votes does A have? A only has 18, right? How about B? Well, looks like B is the first place votes in this column, and B still has this column here, right? Okay, and so that's 12 plus 4, and that's 16. Look at what happened to C. C had 10 people who originally chose C to be the first candidate. And because now D is gone, C has picked up this column and this column, right? So C has now 10 plus 9 plus 2. That's 21 people voting for C. If D and E are not available, C would actually have more votes than others. Which has the lowest? 16, that's B. So B is eliminated at this point, okay? All right, so let me go ahead and write that. B gets eliminated in the third round. Who is being eliminated so far? E got eliminated first. D got, so E gone. And then D gone. Now B gone. Okay, so who is left? A and C are the only only ones left, right? Okay, so look at A and C. I'm going to reset and start again. Okay, I cleared this table, the preference table, preference schedule. Okay, remember only A and C are left, right? So because E, D, and B are now gone, I'm going to just cross out D. I mean, E is already gone from this. So let's cross out D and B. B, D, B, D, B, D, B, D. Okay. All right, so you only have A and C, right? And who prefers A to C? Well, that's this 18 people. Right, and then everybody else, it's CA, 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 CA. All of these other people prefer C to A, right? And this is now pairwise comparison, just like we had before. And so the number of first place winners or the first place votes are 18 for A. Everybody else, which is what, 37? Yeah, people for C. Okay, and they add up to 55, the total number of votes. So by the instant runoff vote method, C is actually the winner. C wins. Okay, We have had an interesting situation here. In the first method, which is plurality, A won, right? In the second method, Condorcet, surprisingly, E won, right? Because E is preferred over everybody else. And in the instant runoff voting method, we found out C is the winner. So who won? Who won this election? Well, that depends on which method is used to decide the winner. Okay, and that is important again, especially in a democratic society in which we live. All right, number 4, and this may be a pretty intuitive one. This is often used in choosing like the MVP of in a sport or something, and it is to give points. Okay? It makes sense, right? Because we want to consider everybody's opinion. We want to give points this is a point system, and this was originally conceived by another French philosopher or political scientist named Borda. So this is called the Borda count method, or simply Borda count. In this case, if 5 people are running like A, B, C, D, E, the last place gets 1 point. All right, so every time you get a first place vote, you get a point. Every time you get a 4th place vote, you get 2 points. And then 3 points for the 3rd place, and 4 points for a 2nd place vote. And if you get a 1st place vote, each of them will count as 5 points. Make sense? Yeah, it should make sense, right? It's going to take a while to calculate this, and you may have to get familiar with this kind of a calculation. It involves multiplication and addition, but you can do this, and let's go ahead and try to do this. Okay, how many points would A get? Here's the way to do this. A looks like how many? So how many first place votes does A have? Well, it's got only one column where A is the first place choice, right? So 18 times 5, that's the number of points A will get by the number of first place votes, which is 18. Now, does A get anything else? Well, A doesn't appear as 2nd place or 3rd place or 4th place, but A appears a lot in 5th place. And in fact, that's 37 votes. In the 5th place, right? So 37, maybe I should write it this way, okay? You have 18, right? And how many 2nd place? Because each 2nd place gets 4, right? And how about 3rd place? And how about the 4th place? And how about the 5th place? Okay, this is probably better. Okay, in fact, I'm going ahead and do this for all the candidates. You see what I'm talking about? See, this is the number of first place votes. This is the number of 2nd place votes. This is the number of 3rd place votes. This is the number of 4th place votes, and this is the number of 5th place votes, right? Because by doing this, we are going to get the total number of points A will get. And in fact, I'm going to set this up for all other candidates while I know what I am doing, okay? All right, and not surprisingly, I will ask you to do these computations. I mean, these are simple computations. It's just cumbersome, and maybe it's annoying. It's not short, okay, but it's not hard. So I'm sure you can multiply and add up these numbers. All right, so A gets 18 times 5, that's 90 points on this column here, and A gets 37 from all these other columns combined, right? And so that would be 90 plus 37. The total points for A is 127. This is like the Olympics. How many points does A get? 127 points for A. Okay, great. Let's do B. All right. How many points does B get? All right. So this is a little tricky. And how you do this sort of depends on what you feel is comfortable. I tend to do it this way, like write down all the things that you see here. And then I ask, how many first place votes does B have? And so now you're looking at this chart sort of in the sideways. It looks like B gets 12, right? So 12 first place votes. Now, how many second place votes does B have? And it looks like it's 10 and 4. That's 14. You see that? Because B appears twice in the second place votes row, and that's 10 plus 4, that's 14. Okay, and then you look at the third place. How many third place votes does B have? None. How many fourth place? Well, B appears twice. That's 9 plus 10, that's 11. And then how about B in the last place? That's 1 and that's 18, right? So that gives you the number of points B gets. Let me just make sure we have this correctly. And if you add up these numbers, it adds up to 156 points for B. Okay, now let's do the same thing for C. Again, I will look at this chart sideways. C appears here, which is 10 first place choice votes. And then C appears in 2 columns for second place, right? So it's 9 plus 2, and that's 11 people choosing C in second place. So C gets 11 votes with 4 points. And then C also appears, no, C does not appear. C does not appear at all in the third ranked position. C appears several times as the fourth ranked candidate. That's 18 plus 12 plus 4. That's 34. So 34 times 2. And then C doesn't appear any in the, as the fifth choice vote, right? So C is going to have 50, 44, and what is that? 68. And if you add up these numbers, C ends up with 162 points. Okay. Of course, when they actually use the Borda count, they use computer or spreadsheet, and that would make it easier. Okay, I forgot the 0 here, so I guess I should put 0. Okay, how about D? Let me erase my markings. Okay, how many first place votes does D have? And the answer is 9. Right, that's this. Now, does D appear as the second place votes? Yes, 18 times. Okay, how about third place? Oh yeah, several times, 12, 4, and 2. You add up those, and that's 18 third place votes. D appears 10 times as fourth place votes, so 10 times 2, and then nothing, right? No fifth place votes for D. So you add up these 4 numbers, and D actually gets 191, and that seems to be a lot of points. Why does D have so many points? Notice here, D actually have a lots of votes in the upper half of this chart, right? 9 votes for D in first place. Second place, you have 18, and then for third place, you have 12, 4, and 2, and that's 18, right? So D has a lots of higher ranked votes, and that gives him many points. So D earns many points because D seems to be generally a likable person, right? So that's why D ends up with a large number of points. Finally, for E, E has 6 first place votes. E appears on this column as their second place choice, that's 12. And E appears in these 2 columns as the third place choice, that's 10 plus 9, that's 19. And then E does not appear anywhere else, okay? So 0 and 0, is that right? Yeah, E doesn't appear in any of the fourth or fifth place choices. That's interesting. E actually is only first, second, or third place votes of everybody. Okay, so you add up these numbers, and this adds up to 189 points. Let me just verify this before we go any further. Yeah, something is wrong here, because if you add up these numbers, you don't get that. And my mistake was this. All right, so E, I forgot this part here. So E has again, 6 first place votes and 12 second place votes, but this number is actually not correct. Why? Because E has this column and this column, and then somehow I omitted that column 18. So E has actually many people voting E as the third favorite candidate. That's 18 plus 10 plus 9. That's 37. So this number is actually 37. Okay, a very large number. And so if you do this, you actually get the correct answer. I wrote down 189 points. Okay, now take a look at all these points and see who the winner is by Borda count. Right, the winner of this election by Borda count is D. Now, D did not win in any other methods, right? So we have now a fourth winner of this, depending on how you calculated this, right? A won by plurality, E won by Condorcet, C won by the instant runoff, and now D is the winner by Borda count. Right, so I hope you have seen that, this is very method dependent. So you have to decide what method you use before you ask people to rank their candidates or cast their ballots. All right, and so I hope you have seen that this method is really important. Okay, and it could change tremendously who the election winner is going to be. All right, then one last one. This is very different method, so I'm going to separate this from everybody else. But there is a fifth, and in fact, there are many other methods of voting. But the fifth method we are going to look at, this is the last one, is called the approval voting. All right, in approval voting, we are not going to ask people to rank their candidates, but instead we ask for approvals. We ask them to do a check mark. Okay, so whoever gets the most approvals wins in this election method. So here, instead of ranking candidates, right, each voter is to approve the candidates of their choice. And so a person can approve 1, 0, 1, 2, or all of the candidates. Okay, so here's an example of this. Okay, again, each voter can approve no one, 1, or more, or all of them. Okay, whoever they think, oh yeah, that person can do the job, then that voter can put the check mark. All right, so in this another election, there seems to be how many people? 80 plus 15 plus 5, that's 100 people casting their ballots. Okay, and out of these, let's see, 80 people said yes, A is good, B is also good, but C is not going to be good enough. So 80 people voted for A or B. Okay, now again, the people did not rank A, B, and C. 80 people simply approved A and B, but not C. 15 people approved B and C, but not A. 5 people also approved B and C. Okay, so that is the that's a little strange. Let me check my notes here. Okay, let me give you a little more detail. Now, here's what's happening in this table. So 80 people, that's the first column. Okay, these 80 people actually prefer A. Okay, so if you ask these 80 people to rank the candidates, they would prefer A, but they also feel that B is good enough to do the job, okay, but not C. Okay, so these 80 people, they would rank them A, B, C in this order, but A and B are good enough, not C. So they will consequently approve or put the check mark by A, B, but not C. Now, the next 15 people prefer B, but they also think C is okay, but not A. So B and C gets check mark, but not A, right? Now, these 5 people prefer C, that's their favorite candidate, okay? But they think B can also do a good job, but not A, okay? So they, even though they prefer C, they also believe B is okay. So consequently, they will have a check mark by B and C. I notice here in the approval ballots, these 15 and 5 people will have identical check marks. right? Both B and C are approved by these two groups of people, but in reality, their favorite candidates are different, okay? The first 80 people would rank A, B, C in that order. 15 people would choose B, C, A in their order, and the last 5 people rank them in C, B, A in that order. But when they do the approval method, then the 15 people and 5 people would have the same types of approval because they think both of these people think, or both of these groups of people think that B and C are okay to do their job. So if that's the case, by plurality, of course, A would be the clear winner, right? I mean, after all, 80 people, a vast majority, a super majority of the people choose A to be their best candidate. But by approval, guess who wins? Well, look, B gets approved by everybody. So B is the winner with 100% approval. Sounds exciting, right? Like, well, wow, B gets an approval by everyone. Even though 80% of people strongly prefer A, but they approve B. 15 people approve B and C, 5 people approves B and C, and therefore everybody approves B. So is that fair? Well, that depends on who you ask. Okay, but before we go to that question, let's try to figure out what approval voting is doing. All right, so I hope you can see that this method picks the one disliked the least, not liked the most. Do you see the difference between these two? A is liked the most. A is preferred by most people. But in the approval voting, the person who is liked the most is not the one that's going to be chosen. In approval method, the person who is disliked the least will get to win. And so that's the difference. Now, let me ask you this. Which one is the best practice, or which one is going to be the most or the fairest way to choose the winner? Okay, so the answer is, well, that depends, right? And that depends on who the candidates are, and also depends on whether you are one of the candidates or not. All right, but we define, in order to decide what the best election method is, we can define what is known as the fairness criteria, just like we did for the apportionment method. After we decide on some fairness criteria, and for these you must see the textbook because we don't have the time or the resources to explain all of these in details, right? But for instance, you say, well, if a majority of the people vote for one candidate to be the first place candidate, that person should win, right? And that sounds fair. And if that fairness criterion is violated, you would think that the method is not fair, right? So the experts and the people in general decided on a set of fairness criteria, what defines the election method to be fair. Okay, so these fairness criteria were defined and decided and mutually agreed upon by many people, experts, right? So we define fairness criteria to define what we mean by fair. Okay, we define fairness criteria to define what is fair. And guess what? Kenneth Arrow, economist, a mathematician, but more of an economist. Okay, he back in 1952 mathematically proved that it is impossible for a method to satisfy all fairness criteria. In fact, what he did is he basically said every possible method of election or voting is going to have the possibility of failing one of the fairness criteria. And in other words, basically he said it's impossible to have a method which is completely fair all the time. And so his theorem, because he proved it mathematically, it's a theorem. So Arrow's impossibility theorem of 1952 states that there is no voting system that is always fair. And for this, Kenneth Arrow won the Nobel Prize. You know, there is there is no Nobel Prize in mathematics. I don't know if you knew that. And there is rich history behind it. It involves sort of an affair that Alfred Nobel was involved in, and all the ugly drama. But there is no Nobel Prize in mathematics, but there is one in economics. So Kenneth Arrow won the award, the Nobel Prize in economics for this work called Arrow's impossibility theorem, which states that there is no voting system that is always fair. And the fairness is defined by these fairness criteria. Okay, so if you look in the book, there are many other methods, including Copeland's method. Okay, but if you have any kind of questions in your homework that asks you to do Copeland's method, just ignore them, okay, to be skipped. You do not have to worry about Copeland's method or any other methods that are mentioned in the exercise section of this. I did not assign you anything that requires Copeland's, but if as a part of the homework questions, if Copeland's method is mentioned or any other methods are mentioned, you do not have to worry about those. Okay, so I will hold you responsible for these 4 + 1, methods, 4 methods involving the preference schedule, and the last one involving the approvals. These you do need to know, but the other ones you do not have to worry about. Okay, so your quiz for section 8.3 involves you and your friends deciding to take a vote on where to go to have some fun. You want to go to San Diego, Las Vegas, or Ventura? It's a small group, and you cast votes and cast the ballots and see where you want to go. And you apply these different methods to see where you would end up with. Okay, so that is your assignment, but actually that's your quiz for this section. And once you complete this on this piece of paper, you should go to the online quiz for section 8.3, followed by these exercises you are assigned for section 8.3, and that should be your very last homework assignment from the textbook. Okay, so this concludes chapter 8, as well as the entire contents of the book. Now, there may be some optional sections that you may study for your section, so ask your instructor. But otherwise, it's been great studying these wonderful topics. And now it is time to get ready for the last parts of your semester. So have a wonderful day, and I will see you again, hopefully, when we talk about the final exam.